Let's see some examples. There is an example that design a 2-stack PDA for the given language, and the language is a to power n, b to power n and c to power n, where n is greater than 0. Right? Now, first of all, let's see the transition function for this PDA. The idea of this language is that at Q0 we read all the A's, at Q1 we read all the B's, at Q0 we read all the A's and push all the A's in stack 1. At Q1 we read all the B's and push all the B's on stack 2. At Q2 we read C and pop both these stacks, and finally we reach the final state. Now these are the transitions here. The first transition is that we read first symbol. See, the language is a to power n, b to power n and c to power n. Okay, so the string will be number of A's followed by number of B's followed by number of C's. Means we will be having equal number of A, B and C's. Suppose the string we have taken is there are 5 A's followed by 5 B's followed by 5 C's. Okay, and this shows the end of the string. Now let's see the transition. We start with the initial state Q0. Okay, we read first symbol. Initially stack 1 is empty, then we push A onto stack 1. We read symbol A and we push it onto stack. Next, now we read next symbol, or we next A we read. Now the top of the stack is A, stack 1 is A. Then again we push second A also onto stack 1. Now using this transition we read all the A's and push all the A's on stack 1, and the stack 2 will be unchanged. We don't make any changes to stack 2. As soon as we get B on Q0, the stack top is the stack 1. Top of stack 1 is A. We don't do anything to stack 1 now. We read B, then initially the stack 2 is empty. On reading B, we push it onto the stack 2. We go to from Q0 to Q1. Now at Q1, stack 1 will be unchanged. We don't do anything with stack 1. At Q1, we will read B and push it onto stack 2. Now using this transition, this particular transition, we read all the B's and push onto stack 2. At Q1, when we read C, stack top of A is stack top of stack 1 is A and top of stack 2 is B. Then we pop both the stacks and we go to state Q2. Now at state Q2 we read symbol C and we pop both the stacks. Okay, so at state Q2 we will read all the C's and we will pop all the A's and B's. Now obviously if we will be having equal number of A, B and C, then only the stack 1 and stack 2 will be emptied. Then finally, when the entire string will be read, then this shows the end of the string, means we have read the entire string. Now by this time the stack will become empty, stack 1 as well as stack 2. Then we go to the final state. So this is the transition diagram for 2-stack PDA. Now let's see the transition functions. Starting with Q0, we read A. Initially both these stacks are empty. We read A and push on to stack 1. Using this, we read A. Top of stack 1 is A. We push this onto stack 1. Now, initially both these stacks were empty. After this transition, the stack positions will be like this. We push A onto stack 1, whereas we don't do anything with stack 2. In second step, using the second step, we push all the A's in stack 1. In third step, we read B. The top of the stack is A. Obviously, the top of stack 1 is A. The stack 2 is empty now. What we do? We will push this B onto stack 2. Now, this will become the stack position. Now, we have read all the stacks in stack 1 and we have started reading B and pushing it onto the stack 2. So, here we have read first B and pushed onto the stack 2. Now, using step 4, we will read next B. Here, from Q0, we go to Q1. At Q1, we read B and we push it onto the stack. Using this step, we push all the B's on stack 2. Now, at step 5, we are at state Q1. We read symbol C. The top of stack 1 is A, the top of stack 2 is B. Then we go to Q2 and we pop both these stacks. Okay, so initially, means earlier, I had 5 A's and 5 B's. After this step, in stack 1, we will be having 4 A's and in stack 2, we will be having 4 B's. This should be B here, not A. Okay, so make it B. Okay, so we will be having 4 B's in stack 2. Now, using this step 6, we are at state Q2. We read symbol C. Top of stack 1 and 2 are A and B. We remain at the same state and we pop both the stacks. Now, using this step again and again, then what will happen? Both these stacks will become empty. Now, at step 7, we are at state 2. By that time, we will be reading entire string, means we have read the entire string. That's why epsilon is here. And both these stacks has become empty. Then we go to final state and both these stacks will remain empty only. So, by reaching final state and by emptying both these stacks means we have read or we have accepted the string of the language A to power n, B to power n and C to power n. Now let's take another example where the language is A to power n, B to power m, C to power n and D to power m. So if we take a string of this language, then we may have 3 A's followed by 5 B's followed by number of C's which are equal to the number of A's. Okay, A to power n and C to power n means number of A and C are equal. Similarly, we have B to power m and D to power m means number of B and D are equal. So number of A's followed by number of B's followed by number of C's which are equal to number of A's followed by number of D's which are equal to the number of B's. Okay. So the idea of this PDA construction or two stack PDA construction is we will read A, we will push it onto stack 1. We will read B. We will push all the B's on stack 2. When we will read C, we will start popping the stack 1. Okay, then only what will happen, if we will be having C and A equal numbers, then what will happen, when we will read C, the stack 1 will become empty. Okay, now when we will read D, then we will start popping stack 2. So if number of B's and D's are equal, then the stack will become empty and the string will be accepted. Okay, so start with Q0. We read the first symbol A. Initially both these stacks are empty. We remain at the same state and we push A onto stack 1. In state 2, at Q0 we read next A. Top of stack 1 is A. Stack 2 is empty now. Then we push this A also onto stack 1. Now using this step number 2, I can push any number of A's onto stack 1. Okay, here I have 3 A's, means I can push all the A's using this step. Now at Q0, when we read B, top of stack 1 is A. Obviously we have pushed A, then top of stack 1 will be A only. Now the second stack is empty. What we will do? We will push this B onto stack 2 and go to Q1. Now this at Q1 we read B. Top of stack 1 is A. Now top of stack 2 is B, because we have pushed one B. Okay, so this next B is also pushed onto stack 2. Now using this step, we can push any number of B's on stack 2. So here we have 5 B's, so we can push all the B's on stack 2, right? Now at Q0, when we reach C, top of stack A, stack 1 is A, we start popping this stack 1. So what we do? At Q1, we reach C, we go to Q2 and we pop stack 1. Okay, the stack 2 is unchanged. We don't do anything with stack 2. Then at Q2, we read next B. Top of stack A, stack 1 is A, top of stack 2 is B. Again we pop the stack 1. Now using this step, we can pop any number of C's. Any number of A's. We will read C and we will pop A. Okay, so if the equal number of A's are there, then equal number of C's will be read. Okay, so we will read C and pop stack A. Finally what will happen? The stack 1 will be empty after this step. Now at Q2, we will read D. Now stack 1 has become empty. Top of stack 2 is B. Now we will start popping this stack 2 also. At Q2, we will read D. We go to Q3 and we pop the stack Q2. We pop the stack Q2. At Q3, we read D. Top of the stack is B. We remain on the same state and we pop the stack. Now at this step, we will pop all the symbols from stack 2. Okay, we will read this B and this D and we will pop stack 2. So finally what will happen? At Q3, we will read entire string. Both these stacks will become empty. Then we go to final state and this stack 1 and stack 2 will remain empty only. Means we have accepted the string. This is the transition diagram for the language above. We start with Q0. We read first symbol. We push onto stack 1. Stack 2 is unchanged. At Q0, we read all the A's. As soon as we read B, we push it onto stack 2. At Q1, we read all the B's. Okay? At Q1, when we read C, we start popping stack 1 and go to Q2. At Q2, we read C and pop stack 1. When we read D, we go to Q3. We read D and start popping Q2. At Q3, by that time we have read the entire string, then the string will become empty. Both these stacks will be empty. Then we go to final state. Let's see one more example. Stack PDA is equivalent to Turing machines, and Turing machines can be designed as an acceptor or as an generator or as a computing device. So this is an example which shows as a generator. In this, what is happening? We have a string W and it generates this. To stack PDA generates this string WWR. Okay, and the output will be stored in stack Q2 in stack 2. Okay, on the input tape this string is given and it will generate the output. This is W. Okay, and the two stack PDA will generate the output WWR and the output will be stored in stack 2. Okay, so this is the phenomena. Now let's take step 1. The idea is whatever symbol is read is pushed onto stack 1 as well as on stack 2. Means on both these stacks this entire string will be pushed, and after that stack 1 is popped and the string is pushed onto stack 2. So as we know that stack has the property of last in first out. So when we pop the symbols of some stack, the string is popped in the reverse order. Then obviously when we will pop the stack 1, the symbols will be popped in reverse order and we are pushing these symbols onto stack 2. Then obviously the stack 2 will contain W and above this we will be having WR. This will be the reversal of the string of W, and वो कहाँ से आ रहा है? We are getting that from stack 1. Okay, so look at this. We start with Q0. We read symbol A. Initially both these stacks are empty. Then we push this A on both the stacks. Now here the string is starting with symbol A. It may happen that this string starts with symbol B. Then in that case, if the string starts with symbol B, initially both these stacks are empty, then we push this B onto both of the stacks. Now in the second step we read next symbol. Now the next symbol may be A or it may be B, and the condition of the stack may be that both the stacks may contain A or both the stacks may contain B. Okay, so let's see all the cases one by one. We are reading symbol A and contents of both these stacks are A. Then we push A onto stack 1 and stack 2. We are reading A but the contents of both these stacks are B. Then we push this A on both the stacks. Now this may be the scenario that we are reading second symbol B or next symbol B, but the content of both these stacks are A. Means the top of both these stacks are A. Then we push it onto both these stacks. Or scenario may be that we are reading B and the top of both these stacks are B. Then also we push B on both these stacks. Means using these steps, what are we doing? We are pushing all these symbols on both the stacks of the string. Right? This is the string. Now, at Q0, without reading any symbol, top of the stack may be A or top of the stack may be B. Then what we do? We pop stack 1 and push it onto stack 2. Then in this case, if both the tops are A, then we are popping this A and pushing it onto stack 2. So this is the scenario. Okay. Now condition may be that both these stacks are having top symbol as B. Then we are popping this stack 1 and pushing it onto stack 2. Or now the next condition may be that top of stack 1 is A and top of stack 2 is B. Then also we pop this symbol and push it onto stack B. Similarly, this step means using these steps we are popping stack 1 and pushing the corresponding symbol onto stack 2. Okay. So after reading entire string, after popping all the symbols of stack 1 and pushing all the symbols on stack 2, then what will happen? We will go to final state. Stack 1 will be empty, but stack 2 will contain WR. Means this WR will be the top of the stack 2. In fact, it should be like this. This WR should be top of stack 2, and below this WR we should have this W. Similarly, if this is the case that the last symbol of this stack 2 is B, then this WR will be at the top of the stack 2, and below this we will be having this W. Okay. Thank you.